All right. Well, thank you very much, and good morning, everybody. So we're going to start with, as Jim calls it, roller coaster corn. Some of you may hear me call this ugly corn syndrome. Basically, that transition period that we often see this time of year when corn goes from living on the seed to living on its own, kind of getting weaned away from the seed and the reserves that are stored up in that and going to living on the soil. So what's happening right now, we've got a lot of corn that has gone or is going through this transition that generally happens around V2, V3. So you get corn that's about 3 collars tall. It's going to go from living on a very nice reserve built up into the seed and go to living on a very young developing root system that quite honestly doesn't have much of a footprint in the soil. So that can lead to some issues or at least some temporary setbacks for the corn plant, depending on the weather conditions at this stage, as well as your fertilization techniques and how much plant food you've put into that small footprint that's taking over. So we're going to transition from that seminal root into the nodal roots at this point in time. And so a lot of things can happen here, and most importantly, what's happened this year to cause some of the uneven corn that we're seeing right now. So during this transition, in that V3, V4 stage, a period of cool and wet conditions can slow that root growth, slow that plant's growth. And this year is no exception. We had a lot of cold weather over the last couple of weeks. Recently turned warm, and we'll talk to that in just a moment. But that cool conditions basically slowed that corn plant's growth and subsequently that root growth in the soil. So that footprint that's fairly small, that will fit inside my coffee cup, sometimes is a little bit small. So instead of looking at a larger coffee cup when that transition occurs, it's going to be on a smaller one, and subsequently the amount of surface area that root represents and the ability to absorb nutrients is smaller at that. So you can end up with some temporary nutrient deficiencies that we'll kind of go through that will slow that corn plant down even further and give you some symptomology characteristic of those deficiencies. So we've had that cold temperature and those cold soils. We had soil temperatures get down into the high 40s, at least locally in northern Illinois, about 10 days ago when that frost happened and the few days past that. So at that point in time, you probably wouldn't want to sit on the soil. So living inside of it as a young plant is probably going to cause things to slow down a bit. But since then, we've had warm weather. We've had very warm weather, in fact, into the lower 80s, and things are growing very rapidly. So take that slower to develop root system and couple it with rapid growth, and basically you accentuate those deficiencies or those limitations until that root system can grow a little faster, because the above ground ambient temperature is much quicker to warm than the below ground where the roots are growing soil temperature. So you get this discrepancy in growth rates between the two, and you can see that flash of nutrient deficiency show up very quickly. So anyway, so that's how this roller coaster starts. You'll see this occur throughout patterns within the field. So it may be a pattern such as nutrient availability based on tightness of the soil or organic matter level. The more adverse the conditions, so the tighter the soil or the sandier the soil, the more you're going to see this start to happen. So that's kind of where it starts. Some of the things that we're going to see, you think about that soil and its ability to mineralize nutrients or to get those nutrients out of it. That's also going to slow down. So naturally occurring release of nitrogen, of sulfur, of micronutrients being released off the soil, CECs, is all going to be slower and further make this show up. So some of the things that we're seeing right now include these nutrient deficiencies, some herbicide injury. So kind of coupled with this slow growth or this transition period also is the thought that any herbicide that needs to be metabolized by the plant is going to be just another stress on stress type of reaction. So if possible, if you have corn that's going through any of these symptoms and you have the ability to wait a couple days for it to recover or grow a little bit better, delaying those herbicides that need to be metabolized, such as the dicambas and such, would be advantageous, just to make sure we're not stacking stresses on stresses. And then we'll go through a little bit on fallow corn syndrome. 2015 has tails that extend into 2016. We'll kind of talk a little bit about that. So nutrient deficiencies, as we look at what we're seeing right now, like I said, that limited growth and that slow mineralization coupled with some of those lighter organic matter spots, you're getting sulfur deficiency showing very prevalently throughout the Midwest, especially in the eastern part of the U.S. where it's been colder and wetter, and that mineralization is showing up at a slower pace. So one of the things to keep in mind is those that maybe peeled back a few expenses and pulled some of the sulfur applications down or out of the mix for this year, that's where it's going to show up a little bit more. Also, if it's broadcast versus banded, that's gonna show up a little bit more as well. So the more you can concentrate any of the nutrients into the footprint of that corn plant, into the flower pod, as I call it, the better you're going to be at removing some of these deficiencies showing up. Just to give you a little perspective on why 360 and the rest of the agronomic world has been talking about sulfur so much over the past few years. If you look at the sulfur deposition map here, so this is basically showing how much sulfur we're getting in the form of acid rain in 1989 versus 2009. And so over the course of this time period, we had a lot more environmental awareness, as well as the advent of government regulations on scrubbers on power plants and coal producing power plants and other sources. So you can see that in the eastern U.S., east of the Mississippi River, we had 30 years ago, 25, 30 years ago, we had a lot more sulfur being naturally deposited. Now, the folks in the western corn belt probably have been using sulfur in their rotations a little bit more because they did not have the unfortunate advantage of having the acid rain deposit the sulfur via acid rain. So if we go forward, you'll see that deposition is much less, and subsequently that sulfur in the soil just isn't there. And so we've had to add that to the mix over the past few years, especially as the coal industry, one, gets cleaner, and two, starts to subside in lieu of other energy sources. So at that point in time, so we need to focus on adding this into the corn crop. One of the things to keep in mind with regard to sulfur is that of the 21 amino acids, 2 of them create or contain sulfur. So we need to make sure that we keep that 10-to-1 ratio of nitrogen to sulfur. So, if you're going to apply 200 pounds of N for your crop, you probably need somewhere in the area of 20 pounds of sulfur for the corn crop as well. So other nutrient deficiencies that we're seeing, obviously zinc can show up, especially in cool and wet conditions, or certain pHs that will exacerbate the situation. So if zinc was not added to a starter or a 2x2, chances are in these conditions of cool and wet, you can see that start to show up. So one of the things we need to do, and I grabbed this photo from a nearby field yesterday that you see on the bottom. You can see the sulfur deficiency showing up via the lighter organic matter areas of the field. So sulfur is something that the corn plant needs throughout the season, as you've heard us talk about before. Typically want that 10-to-1 use ratio. So if I'm going to apply 200, I want about 20 pounds. And keep in mind that this nutrient is almost as leachable as nitrate. So if we think about trying to front load sulfur the same way that we typically have in the past, or some of us still do nitrogen, if you front load it, the chances of losing it are increased. So as we go through time and we evolve our nitrogen program, sulfur needs to kind of piggyback on top of it and be spread throughout the season. So putting all of your sulfur out in the form of AMS in the fall, especially if you're going out there in October trying to get some stalk degradation happening, chances are you're not going to have that full regiment of sulfur still available in the spring. So adding it into the side dress applications through potassium thiosulfate KTS or ammonium thiosulfate ATS, as I do, can help make sure that you have what you need. The use curve of sulfur looks very similar to nitrogen in that we use a lot of it late season. Therefore, we want to make sure that we have it late season. So just a background. Of the roughly 7 to 8 gallons of ammonium thiosulfate that I'll use this year, so 3 gallons went on with the planter 2x2, and then the other 4 to 5 gallons will go on in the form of Y drop banded at the plant, obviously throughout the season this summer. So I'm trying to stick to that 10-to-1 ratio and practice what we're preaching in order to make sure that I don't lose the product, especially as you go across sandier areas of the field.
Hey, Matt.
Yes, sir.
So we've talked about, I've got a question here, we've talked about cool, wet soils. What about hot, dry soils? How do they impact the phenomenon you're talking about? Is it similar or different? Some parts of the eastern U.S. tend to be hot and dry, so tell us a little bit about that as it relates to mineralization and micronutrient availability.
Yeah, so hot and dry can have a somewhat similar impact at the end of the day. Mineralization requires kind of a happy place as far as temperature and moisture. If we get too hot, if we get too dry, it will slow down that mineralization. You think about nitrate tests that you send off to the lab. If they're moist and they get hot, it'll increase the mineralization of nitrate. But on the other hand, if they're hot and they're dry, that nitrate mineralization doesn't happen. So same thing with natural mineralization in the soil. If we end up with a couple of 3 top inches of the soil being very dry, and that's where our root system is for the most part in this early stages, then we're going to end up with potential issues with availability. Basically, the nutrients aren't being mineralized by the soil, and therefore you could end up with deficits as well. So the soil can be inhibited from its release of nutrients by either being too hot and dry or too cold and wet, and the plant can be likewise affected. Root growth doesn't happen as well in dry soils, so you're not going to explore as much volume. Likewise, if it's very wet, it doesn't happen. So it's a little bit of a Goldilocks phenomenon. To get it exactly right, you need it to be just right in the soil or somewhere nearby. So hopefully that addresses that question. If not, we'll add more onto it. With respect to other things, I mentioned the herbicide injury. These cool and wet conditions. You know, a lot of our herbicides are metabolized by the plant, and therefore, if we're cool and wet, we can end up with variations in our crop due to this. A lot of this has been abated over the last several years. We're using less volume on pre's. Our rates are a little bit lower, and therefore we're probably not tickling that upper end of the rate range that sometimes ends up giving us herbicide injury. But if you have super high pHs, in certain areas, you can end up with this happening going forward. So fallow syndrome is something that we're seeing this year show up. I have some on my own farm that I've noticed over the last several days as some of these low-lying areas transitioned from seed to seedling roots. Fallow syndrome, basically, if we had ponding last year, and we all had lots of rain for the most part last year, where we had ponds, if those ponds basically stayed barren, didn't have crops, didn't have weeds, whatever it may be growing on it last year, one of the side effects of that is the microbe factory in the soil basically won't be there in the levels needed to help, especially the mycorrhizae that help promote the transfer of into the plant. You'll see oftentimes these white webby looking fungi complexes in the soil, and that's what we need in order to get phosphorus into the plant in a very, very efficient way, especially when we don't have much root system to start with at a young stage. So in where we had flooding and we thought we were doing the right thing by going out and killing all the weeds out throughout the year, or maybe we killed them, whatever it may be, if we didn't have a quote unquote green bridge to keep that soil living, then we can end up with this. So what do we do about this? What we need to think about is not necessarily for this year, but going forward. There's not a lot of rescues for fallow syndrome. So it's more of a conscious effort to avoid it in the future. A couple of ways you can do that. If you have those ponds, having some sort of grass species growing on it, whether that's unintentional by letting foxtail grow in it, at least for a little while throughout the summer before it sets seed, or whether it be putting a cover crop that includes a grass species into it, will help rebuild that mycorrhizae population so that over the course of that summer and into the fall, that will build up and you won't see this problem. If you keep that barren ground throughout the summer and fall, you will end up a lot of times with this occurrence. The other way to avoid it, if you know you're going into ground that was ponded, drowned out last year, you can ban phosphorus-containing fertilizers at the row at planting. Basically stack the odds in favor of it being there and being available for the young plant. Unfortunately, I didn't include phosphorus in my 2x2. Next year I will. Even if I don't have necessarily fallow syndrome per se, chances are there's some areas in the field that the mycorrhizae populations aren't flourishing, and therefore adding something into the band isn't a bad idea. So hopefully that kind of clarifies what we're seeing. What we'll see in this is typically those low-lying areas will be purple, just as you'd expect with phosphorus deficiency. That anthocyanin, which is red, mixes with the green chlorophyll, and you get purple leaves. So you're still developing sugars, you're just not able to transport them and transfer them throughout the plant. What you'll see in yield impacts, those areas, you know, if we're going to yield determination, so V5, V6, and we're still seeing those symptoms, we can end up with a little bit of a yield thing. Basically, you know, if the corn plant's not happy going into yield determination, we have ultimately taken some of the potential loss of its top end. Now, is it dramatic? Is it going to be a zero? I highly doubt it. What we're going to see is just a little bit of the top end taken off. As we go through the summer and we have the host plant being corn in that field, that mycorrhizae population will increase naturally, especially if we don't have saturated conditions right now. That will build back up, and this train of events will continue down the track as we go through the summer, and it will recover. So here's a picture of what fallow corn syndrome, just a typical phosphorus deficiency. Looking at that, So give you an idea of what you're seeing. It can explain a lot of the low-lying areas that you do see right now. Some of the yield impacts that are out of the data. There's a lot of good sources online. Purdue's got a nice little piece explaining kind of what's happened. As you can see, based on the mycorrhiza colonization, it does recover throughout the summer as you have that post crop in place, and the yield, while impacted, isn't terribly dramatic, kind of like what we've seen. So banding in the future, as well as a cover crop containing grasses. If you go out with a cover crop of just pure radishes, that's not going to fix it. You've got to have that grass species, whether it be oats, rye, wheat, whatever it may be, have something that allows you to build on that. So there are also had a comment regarding there are some products that do have mycorrhizae in them that you can band at planting. That would also be a possibility to basically inoculate the soil at that point in time. Those products have come out in the last few years. I haven't personally used them myself, but the other people that have seen good results with it. So definitely a possibility, especially if you're going into a field where you know you have the issues.